So, how do I ensure my answer is in simplest radical form? I'm glad you asked. It's your girl Tiffany from Tiffany's Tutoring and Consulting LLC, and I'm guiding you through these education streets. All right, so let's start out with a little bit of definitions, right? So, you can see here the radical sign, and you see the degree is in red in, and the radicand is in blue, which is the X there. So, a lot of students are used to saying square root, and they call it square root, but they really don't know what the degree is of that radical. If you don't see a number there, the degree is two. Now that's a little bit different because typically we're used to if we don't see a number, there's one. So, for example, if I have an x that's there, the coefficient is one. The exponent is one because there's nothing there. But in this case, with a radical, if there's nothing there, the degree is two. And the radicand is underneath the radical sign. Now, a prime number. Why are you telling me about prime numbers, Miss Hickson? I'm glad you asked, but we're going to get to that. A prime number is a natural number with factors of only one in itself. A factor is a number or expression that divides another number or expression without having a remainder. So, all of this is going to be very critical to what we're going to do. So, now we're going to kind of close in on everything and we are going to do some problems. All right, y'all ready? Let's go. So I have problems here that need to be simplified. What I'm going to do is I'm going to start out kind of with the easiest one first and then work my way through. But once you see the process, you'll see it's pretty straightforward. So we have the square root of 40 is our first number. So for the square root of 40, the technique we're going to use is we're going to find the lowest prime number that is a factor of our radicand. Okay, so that's how we start out. So we're going to start over 40. I like to put it on the right hand side. Then I think about it. What is the smallest prime number that is a factor of 40? And oh, it's two. It's not one because two is the first prime number. So two goes into 40 20 times. Again, remember it needs to be a factor so that I don't have a remainder. Again, this is going to look a lot like prime factorization. So stick with me. Follow this same process. The smallest prime number that is a factor of 22. Here we go. Boom. 20 divided by 2 is 10. I put my answer on the right side, prime number on the left side. Same process. Smallest factor of 10, that's a prime number, 2. Boom. Keep going. 10 divided by 2. Again, my answer's on the right, my prime number's on the left. Now, 5, a lot of students will put 2 because they're in that groove of 2. No, stop, halt. You don't want to put 2 because 2 is not a factor of 5. But guess what is? It's 3. No, sir, no, ma'am. It's 5. Okay. And then 5 divided by 5 is 1. So that's what you're trying to get is this 1 in this right column. Again, that's why you can't have anything with a remainder. So now I'm going to put it all together. Because it's a degree of 2, I'm looking for groups of 2. Now, in this case, it happens to be the number 2, but it doesn't have to just be the number 2. It can be any number 3, 4, 5. No, not 4, but 2, 3, 5, because again, 4 is a composite number, not a prime number. Any of those groups are fine, but it's just groups of 2 based on the degree. So I'm going to have 1, 2 represent that group of 2. Now, you see a 2 here and a 5. Well, with those, they aren't groups of the same number, so I'm going to leave them inside the radical. Okay, so that's going to be 2 times 5 inside the radical. I'm going to bring down my group of 2 to come out here, and then I'm going to multiply what's left. Now, I can either multiply on the inside or outside, that's fine. My final answer is 2 square root of 10. Okay, so take a moment, look at the process. Now, let's do the square root of 147. Now, you might be like, wait a minute, 147, that is not an even number. The number doesn't have to be even, it can be an odd number and it can be a composite number. But we're going to start here. So we think about 2. Well, we know 2 cannot is not a factor of 147 because we know that 7 is odd and 2 is even. So and with 2 it has to be an even number at the as the last number. So let's try 3. Okay, does 3 work? Go ahead and put in your calculator and see if it works. Absolutely, it does. And when I divide, I get 49. Here's a little trick to help you determine if it's divisible by 3. If I take each of those numbers and add them separately, so 1 plus 4 is 5, 5 plus 7 is 12. Because 12 is divisible by 3, 147 is divisible by 3. Look, little trick, little hint. Hopefully it'll help you out. All right, so let's keep moving on. So what's the next step? Glad you asked. 49. So we're looking for the smallest prime number that will go into 49 as a factor with as a factor so that I don't have a remainder. 2 doesn't work. 3 doesn't work. We know 5 doesn't work because it's not ending in 5. So guess what? We have good old 7. All right. Great job if you figured out it was 7. So now what we're going to do is we're going to do what? Divide. Again, whatever number we divide, we put in the right column. And then whatever, our answer is in the right column and our prime number is in the left. So what number goes, is a factor of 7 is a prime number? Only 7. Very good. So then I end up with 1 here. Same process, degree of 2 because nothing's there. So what I'm going to do is I'm going to circle that group of 7 and bring it out as a 7, not as a 2, as a 7. Okay. Whatever's left, I put under the radical sign. So that's a 3. And there's a 7 on the outside. So again, this is the process. It's pretty straightforward of a process, but I want you to try this next one on your own. So pause the video so you can get some good work in. All right, hopefully you're back with your answer. So let's see what happened. Again, I'm gonna go a little bit quicker on this one because I know you guys have been doing an amazing job. Again, the biggest issue I see with this is that students kind of like give up, right? This is a big number. You can't give up, and you have to make sure that your numbers are in the right column. Again, your prime number is on the left column, and your answer is on the right column. But again, you just continue to go through this process until you get the answer that you need. Okay. So we're just going to continue to go through the process. Another error I see is that if your prime number is not going to be 2, sometimes for students that can be a little daunting, but you just keep going. Or, like in this case, I'm going to run out of space, but that's okay. I'll just extend my line, a little bootleg, but it'll work. So again, I can see I have all these 2s. So now it's a degree of 2 because there's nothing there. So let's group. I have one group of 2. Sorry about that. Another group of 2. Another group of 2. Another group of 2. Okay, and there's 1, 2 left over. So as you guessed that you should have a 2 in there. Now here you multiply all the 2's together. So I have 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. So I have 16 square root of 2. If you got the right answer, give yourself a hand. All right, so let's go ahead and go to these degrees that are not 2. So the degree of 3. Guess what, y'all? It's the same process. I'm going to find the smallest prime number that goes into 200 as a factor. So it's going to be 2. Okay, I'm going to go through the same process. And you're wondering, wait a minute, when is it going to be different? I'm glad you asked. It's about to be different in just a second. 25, don't let that be a trick. That definitely is going to be 5. And then I'm done. Now, here's where it gets different. The degree is 3. So I'm looking for groups of 3 of the same number. Again, talked about it being like prime factorization. So I put a 2 there. Again, it's 3 2's. It doesn't have to be the number 3, just groups of 3. 5 doesn't have a group of 3. Okay, so I put my 2 outside. And then don't forget, don't do like what I just did. Make sure you have your cube root. So that's your final answer. Okay, not too bad, huh? Let's try the next one. Pause the video so you can see what you got. Okay, we're back again. So again, we're going to go through the same process we just did. We're going to look for those prime numbers that are factors of our answer. And we're just going to keep going through the process. And again, make sure you look out for small errors. It's really important to not make little errors because then it can really mess up your entire problem, right? So you want to make sure that you're looking for any potential errors that you may have. And again, you're just going through this process until you get down to 1. Again, going through the process until you get down to 1. Okay, perfect. Now, hopefully you did groups of 3 when you grouped. So you have one group of 3. So that 2 for that first group of 3. And then another group of 3, which is 3. So when I come down here in the radical, I have a 2 left, and I have a 2 times 3, which is 6 cube root. Sorry. Again, don't make the mistakes I'm making. 6 cube root of 2. All right, guys, hopefully that was helpful. I'm going to come back with a part 2 where we include variables, but you're going to see the variables are pretty easy peasy. All right, talk to you guys later. Peace.